Welcome to the short session on sets. We will develop a few important concepts here that we will need in the study of Boolean algebra. We'll define sets, look at some common sets, and look at concepts such as subset, superset, universal set, and complement, as well as tuples, the set product, and cardinality. We've got 10 slides in this session, and it should take about 14 minutes to complete. The first topic we should discuss is sets. A set is nothing but a collection of elements, and we use curly bracket notation to indicate what is inside, what type of elements are inside the set. As shown on the slide here, the set A contains the elements A and B, and the dots indicate that there are some other elements present as well. Now, some common sets that we have most likely seen and worked with before include the natural numbers, whole numbers, rational numbers, real numbers, and possibly the Boolean domain. The natural numbers are the positive whole numbers, starting at 0, increasing by a whole number at the time to 1, 2, 3, etc. to positive infinity. The whole numbers include the negatives of the natural numbers as well, so we start at minus infinity, increase a whole number at the time to positive infinity. The rational numbers, the set Q, is any number, the set of any number that can be written as a ratio A over B, where both A and B are members of the whole numbers. Any number that can be written as a fraction or a ratio of whole numbers is a rational number. Then we have the real numbers that include any decimal number. This includes the rational numbers and the whole and natural numbers, but also other numbers that cannot be written as ratios. And then we have the Boolean domain that contains only two elements, the elements 0 and 1, and that will be the domain of interest for this portion of the course. Let's go over a little bit of notation that we will see commonly. Starting at the top of the slide, we have this V-looking symbol with a bar in it that means for all. So if you ever see that symbol, just read for all in its place. And then we have a backwards 3 looking symbol that means there exists. And then a vertical bar or a semicolon can be read as given that. And then either a dot or the abbreviation s.t indicates such that. So using those, in our first example, we read there exists elements x in n such that the square of x equals x. So we're saying there exist elements in the natural numbers that equal their squares. We can use this notation inside what's called set builder notation. So what we're doing now is we're simply adding the curly brackets to indicate that the elements that we're describing are part of a set. So what we have here is the same example. We have the example where x squared equals x, but we're now saying, open curly bracket, so we're saying the elements x are a set, and we are also saying that x are elements of the natural numbers given that the square of x equals x. So in the natural numbers there's only 2 where this holds true. 0 equals its square because 0 times 0 is 0, and 1 times 1 is 1. So this happens to be the set 0 and 1, the set of elements 0 and 1. We can use another example here is the set of positive real numbers. So we have open bracket, x is an element of the real numbers given that, vertical bar, given that x is greater than 0. So we saw a set as a collection of items. We should also know that per definition a set does not have more than one single copy of any item, and also that the order does not matter. So the set containing A, B is the same thing as the set B, A. A subset is simply a partial selection of the elements of the superset, the superset being the set with more elements in it. And we can use this rotated U symbol for subset and superset, depending on which way it's rotated. So if the set A contains the elements 1, 2, 3, and 4, and the set B contains the elements 2 and 3, then B is a subset of A. and A is the superset of B. So, per definition, if B is a subset of A, then all the elements of B are elements of A. And if B is a subset of A, then A is a superset of B. And we saw the common sets, the Boolean domain, the natural numbers, the whole numbers, rational numbers, and the real numbers. And it turns out that the Boolean domain is a subset of the natural numbers, since it's only 0 and 1. The natural numbers, since they are the positive whole numbers and 0, is a subset of the whole numbers. The whole numbers are a subset of the rational numbers, since each whole number can be written as itself over 1. And the rational numbers are a subset of the real numbers. Another important concept is that of the universal set and the complement of a set. The universal set, often denoted as the symbol S, is the set of all possible elements in the context of the study. So when we're dealing with Boolean numbers, typically the universal set is the Boolean domain that has all the Boolean numbers in it. And if we're working with natural numbers, typically the universal set is the set of all natural numbers, n. It could be something else depending on the context of the study, but typically it is the domain of the number system we are using. The complement of a set A is the set of elements in the universal set that are not in A. So we have an example here. If our universal set S happens to be the Boolean domain, so our universal set contains the elements 0 and 1, then the complement of the set with the element 1 in it is, and now we can use our notation definitions, open curly bracket, the elements x that are elements of S, in this case 0 or 1. So we have the elements x that are either 0 or 1, given that x is not equal to 1. And that leaves only the element 0.